What did you guys get for the first warm-up? 0, good. It doesn't really matter what all the other numbers are. There's a 0 right here. Anything times 0 is 0, so you don't even really need a calculator or to write out any multiplication. Very simple answer, 0. Any questions on number 1? All right, number 2. This is one of those problems you may remember from algebra class where you distribute. You multiply each term in the parentheses by the number that's out front. Careful, you are distributing a -5. Keep the sign in front of each term with that term. So think of this as a -8. Think of distributing a -5. So you want to do -5 times x first. That's -5x. And then you want to do -5 times -8. That's a positive 40. Any questions on that? Especially the signs. The signs are what get people on those types of problems. All right, next you have to distribute again, but this time twice. 3 times -u is -3u. 3 times -5 is -15, or -15. Now we're distributing a -8, so that's -16u minus 8. Let me know what your questions are. We are not done with number 3 yet, so don't box that in. All right, what can I do on 3 now? Does anyone know? Yes, ma'am?
Are you supposed to you'll do the first one with the last one or something?
Oh, no, that's something else. That's when you're multiplying with parentheses. All you really have to do now is combine like terms. So do you see how these both have u's? What's -3u minus 16u? They're both negative, so Adam, keep the negative sign.
Negative 18.
19u. All right, and here I have a -15 minus 8. So again, they're both negatives. Adam, keep the negative sign. -23, good. What are your questions on today's warm-up? None? All right, set those warm-ups on the side of your desk. Make sure that your name is on them. And here are your notes for today. So go ahead, get your notebook out if it's not out already. You have a notebook quiz on Friday. So make sure you have the section number, the section title, and the objective for all your notes so far. Plus today, plus tomorrow, plus Wednesday. All right, I'll give you a second to catch up. So today we are doing section 2.4. 2.4 is all about vertical angles. Our objective today is to find the measure of angles formed by intersecting lines. Any questions before we get rolling? All right, we have 2 definitions for today. I'll give you some time to write those. First one is vertical angles. The second one is linear pair. Below each definition, draw 2 lines that intersect each other. We are going to label those. One as vertical angles, one as linear pairs, so you can see the difference. So I'll give you some time to write. Do those drawings. We'll finish them when we get there. Vertical angles are two angles that are not adjacent and whose sides are formed by two intersecting lines. So you should have two intersecting lines in your notes, right? The two angles that are not adjacent, those are vertical angles. Okay, so basically the ones across from each other when you have two lines that intersect. So those two that I marked in red, those are vertical angles, and then the little ones on the side, those are also vertical angles. So again, vertical angles happen when you have two lines that intersect the angles that are not right next to each other, so the ones across. Now, the ones that are right next to each other, those are called linear pairs. Okay, so there's a set of linear pairs. Here's a set of linear pairs. Here's a set of linear pairs. Here's a big set of linear pairs. Alright, so any of the two that are right next to each other that form a straight line, those are the linear pairs. Alright, and then the ones across from each other are vertical angles. What are your questions so far? Alright, here's two things you need to write down. The first one is a postulate, the second one's a theorem. As far as you're concerned, those are basically the same thing. It's just a statement that you know is true. So the first one says if two angles form a linear pair, I'm going to underline linear pair. It's all about the measure of those linear pairs, so the ones that are right next to each other. Those are supplementary. What does it mean to be supplementary? They add to 180, good. Alright, next you have the theorem. The theorem is all about vertical angles, so you can go ahead and underline vertical angles when you write that. So if two angles are vertical angles, then they are congruent. What does it mean to be congruent? They're equal. Good. They are the same. Great. What are your questions so far? Alright, there are 5 examples today, so we can jump right in. Here's the first one. It actually has 3 parts. You do not need to write out the instructions unless you want to. They're almost identical to the instructions on your homework, so if that will help you keep that straight, that's fine. But basically on these, we're deciding between whether they're vertical angles, they're linear pairs, or if they're neither. So part A, angle 1 and angle 2, what do you think? Are they a linear pair, meaning they're right next to each other, forming a straight line? Are they vertical angles, which means they're formed by two lines that intersect, but they're the ones that are across from each other, or are they not related in either way? They are vertical angles. See how they're right across from each other?
Yeah.
Those are vertical. Good. All right, part B. Notice, what do they form when you put them together? A straight line. And they're adjacent to one another. So they are a linear pair. Good. All right, and last, this might look like a linear pair because when you put them together, they form a straight line, but are they adjacent? Adjacent means right next to each other. So are 5 and 6 right next to each other? No, you have this guy in there messing it up, okay? So C is actually neither. They're not vertical because they're not formed by two lines that intersect. There's actually 3 lines up there. They do appear to form a straight line, but they are not adjacent. You got a little extra guy in there messing you up. So we have one of each on the board. Any questions on these? All right, here is example 2. Example 2 says find the measure of angle 1. That is up to you. He asked if you have to write the question. I probably wouldn't write the question. I would just maybe put like angle 1 equals and then our answer. That way you kind of know what the question is asking. Now, what type of angles are these? It's a linear pair. They are right next to each other and they form a straight line. Linear pairs should add to what? 180 because they're supplementary. Good. So if I start with 180 and I take away the part I already know, that should give me the measure of angle 1. What is the measure of angle 1? 40 degrees. Good. What questions do you have? So in number 3 now we're trying to find the measure of angle 2. So it's up to you whether or not you write out the question. But I'm going to write angle 2 equals, and then I'm going to write what it equals. You should be asking yourself as you are drawing this, are these vertical, linear pair, or neither? So are they a linear pair? Let's just compare it to the last question. Are these a linear pair? They're vertical. What do we know about vertical angles? They're congruent. So if the one that's vertical with angle 2 is 37, angle 2 is also 37. No subtraction or anything. They are the same because they're vertical. What are your questions on example 3? Alright, here's example 4. You actually have to find 3 different angles in example 4. So this is one where you definitely can't just write your answer and circle it. You got to do some labeling. So we'll have angle 1 equals, angle 2 equals, and angle 3 equals. So again, your trick is to decide if the angles are vertical angles, they're the same, or if they are a linear pair, which makes them supplementary, so you can add them to get 180. When I do these, I always do the vertical angles first. I think they're by far the easiest. They're just the same thing. So what angle is vertical to this 20-degree angle that I already know? Which one's across from it? Not right next to it, across from it. Angle 2. So angle 2 has to be the same. They're vertical angles. Angle 2 is 120 degrees. Or sorry. Take that back. Angle 2 is just 20 degrees, not 120. My bad. All right. Now, I know that 1 and 3 are vertical angles, so once I find 1, I'll have found 3 already and vice versa. They're going to be the same. Does anyone have an idea of how we could find 1 or 3? What do you know about 1 and that 20-degree angle you were given? They form a straight line. What's the degree measure of a straight line? 180. So when you put them together, you should get 180. So I can start with the 180, take away the 20 that I already know. What does angle 1 have to be? 160. Good. If angle 1 is 160, what's angle 3? 160. Those are your 3 answers. Now, like I said on the last one, if you want to go back and then label this 160, 20, 160, and then double check to see if it makes sense, that might be helpful for you. All right? And again, you can double check, do the 2 that are right next to each other add to 180, do the 2 that are across from each other have the same measure. And that does hold true in all the different combinations in part A. What are your questions before we go on to B? All right, I know that one of the angles in B is going to be 130 degrees. Which one is it? Angle 1. Why angle 1? They're vertical angles. They are congruent. So I know that angle 1 is 130 degrees. Now, 2 and 3 are also vertical angles, so they're congruent. I just don't know what their measure is yet. How can I find it? Yeah, subtract what?
180.
And?
130.
Very good. And again, we are doing that because do you see when you put that angle that you already know together with angle 2, you form a straight line? They're a linear pair. Linear pairs add to 180. So do 180, take away the part you already know. That'll give you the measure of angle 2. So what is the measure of angle 2? 50. What's the measure of angle 3? I heard both. It's either 130 or 50. We know that. 130, so you're telling me that these 2 are vertical angles? It's 50, right. Good. And you shouldn't really rely too much on just like the size representation of a diagram, but in this one you kind of can, right? These 2 look like they're the same size. These 2 do not. All right, so as you're finding that last one, you can really use your diagram to help you. Remember, the ones that are congruent are the vertical angles, so not the ones that are touching, the ones that are kind of pointed towards each other. Any questions?
So 1 and 130, they same time?
Yeah, these are vertical angles, 1 and 130, because they're across from each other. So I know they're the same. 2 and 3, I know the same because they're also across from each other. Those are those vertical angles. And you know, vertical angle starts with a V. They kind of form 2 V's if you look at them, like 2 and 3. See how it's like a V touching a V? If that helps you remember that they're vertical angles, they're the same. So I said this earlier, I'll say it again. Basically, all you're doing today is deciding whether they're congruent or whether they add to give you 180. Any questions? All right, here's number 5. These are those ones that everybody loves. Find the value of x. So again, I just said it. You'll probably hear me say it many, many times this year. The trick is to either set them equal because they're congruent or make them add to 180 because they're supplementary. The trick is deciding which one is which. We have one of each on the board. Which one should be congruent, A or B? B, good. B has the vertical angles. Again, if you trace the angles, they sort of form like two V's touching each other, coming together at their points. Those are vertical angles. When they're vertical angles, they're equal. So I'm going to set those two equal. I'll come back to that one in a minute. Can I do the same strategy in part A? Are those vertical? No, if you trace them, you would get two V's, but they would be sharing one side. So they're definitely not vertical. But look here, what do they form? A line. When they form a line, they add to 180. So you can do the two angles added together equal to 180. Now you're basically just filling in the blanks. So the first angle was x plus 10. The second angle was 30. Now they are both set up. It's basically just going back to your algebra skills from here, which for some people is a little trickier than I had hoped, but that's all right. What do I do with that 10 and that 30? They're on the same side of the equal sign. Just add them.
So that's 40.
Good, so x plus 40 equals 180. Now to find the x, subtract. You got to undo the adding. So yes, we subtract. Good. So x equals 140 degrees. Again, it's nice if you go back and take the x out and put the 140 in. That would give me 150 for this angle. Does it make sense that 150 and 30 go together to give you 180? Yeah, now you don't have to do that step, but it's just a nice way to check if you're right, especially if you need to get a good grade on a quiz or something. That's how you check your work on these. Questions? All right, we already started B. These are vertical angles. We said they're equal to one another, so I started that equation. Now, how do you get the x by itself? This is the one where you divide. Good. So here you get that x equals 12. And again, if you plug it back in, you have 2 times 12, that's 24. And 24, they're obviously congruent. So you have checked your work. You can move to the next problem without fearing whether the last one was wrong. What are your questions? All right, here comes your homework. We can do the first two together if you'd like, and then you will be on your own for the rest. All right, it said if two angles form a linear pair, then they are... Linear pairs are... Linear pairs are supplementary. Somebody said it. Good. Remember, vertical angles form a straight line. They add to 180. That's just another way to say that they are supplementary angles. Number 2 says the vertical angle theorem states that vertical angles are congruent. Good. All right, let's just talk through the directions on the rest of this page. Number 3 through 5, that's where you're saying vertical angle, linear pair, or neither. So just use the diagram, say which one it is. If it's not either one of them, say neither. Number 6, 7, 8, you are just finding the measure of angle 2. And it says you're using the linear pair postulate, so you're probably going to do a lot with the number 180 for 6, 7, and 8. Jump down to number 9, 10, and 11. You are just saying which angle is vertical to angle 1. So we did not do any of these this exact same way in your notes. So let's look at number 9. It is asking me which angle would be congruent to angle 1. Which angle would be the same as angle 1? Angle 3. That's all you're doing. It doesn't actually tell you what the measure is for either of them, so you can't really tell me what angle 3 is. You're just saying that angle 3 is the same as angle 1. Number 12, 13, 14. You are finding all the missing measures. So angle 1 equals, angle 2 equals, and angle 3 equals. Those will each have 3 answers. 15, 16, 17. You are solving the equation for x. So first you have to write an equation, then solve it for x. Remember, if they're vertical angles, just set them equal. If they're linear pairs, add the 2 angles together to equal 180, and then solve for x depending on how the problem is. Using inverse operations, so like if you're adding something, subtract it. If you're multiplying, divide, things like that. And then 18, 19, 20, 21, you are using that picture to the right to answer some real-life questions about vertical angles. So make sure you read the directions. The directions tell you exactly what one of those angles is. That'll help you find the rest of them. Any questions on your homework before I let you go? You got 13 minutes. You can probably get this done in class, or at least half of it. All right, good luck.